Hey, what's up guys, my name is Cherno. Welcome back to the Game Engine series. Today we're actually going to start finally looking at some kind of integration with scripting, but don't get too excited because we're not going to start looking at C# or other languages. We're going to start right here within C++. Last time we talked about camera systems. Check out that video if you haven't already. And today, as I mentioned, we're going to be all about the C++ scripting. So let's start a little bit with talking about how we're going to deal with C++ as a scripting language and what that even means. And to demonstrate this a little bit more, we're going to transition into the source code, and I'm going to just show a little bit more about what we're actually going to do here. So at the moment, if we take a look at our game, and I might launch this, it's technically an editor, but we still have some kind of game-related features in there. I think the biggest thing that the biggest thing that prompted me to move on from the camera stuff to the scripting stuff as well, it's worth noting, is the camera system and the fact that we need a way to control the camera. But how do we do that without actually, hard coding it, I guess, or creating like an orthographic camera control class like we've already got? We have no way to move this. We've got components that make this up. We've got two different cameras and all of that's great. We can control the two different cameras and it looks great. We can switch between them. However, I want to be able to move the camera. So with like WASD or the arrow keys, how do I achieve that? Well, currently, if we take a look at our code and how it's laid out, we need to probably manually do that inside the editor layer, but that's not right because even though the editor layer, and this is, I don't want to get too much into this, but technically speaking, if it's an editor camera, you probably would write it like say outside of the game's runtime, obviously, and outside of the entity component system and outside of all that stuff. But when it comes to the actual runtime camera, so say that you're making a game and you want to have a camera entity that obviously responds to some kind of behavior. So for example, maybe it always follows the player. You want it to be part of the entity component system. It has the camera component, which we talked about and developed over the last few episodes. But now we need a way to actually hook in some kind of behavior into this camera entity. And that's where this whole C++ scripting is going to come in. Now, this is something that is moderately complicated, and it's actually something that I've developed over the course of a live stream. I've been live streaming this stuff on Twitch lately. There'll be a link in the description below, twitch.tv/the Cherno. There's also a schedule there, and if you want to catch any of the live streams, they are there, as well as the VODs, so the kind of recorded videos, the videos on demand, that you can go back and watch. So if you want to see the whole planning process of how this works, check out Twitch. They only stay there for 2 weeks, unfortunately, just the way the Twitch stores them. So I will make them accessible to or by patrons as well. So if you want to really catch the whole archive of them, there's like one total video at the moment. And then check out patreon.com/the Cherno and help support this series, and you'll get access to all of that. But basically, the reason I'm saying that is because, long story short, this has been planned over a while with the stream. So what I'm going to get into today is more or less the solution that we all kind of agreed upon, and all the ideas that I gathered from stream, because I was originally going to do it a different way. And that's why I love, this whole streaming thing as well. I think Coder2k suggested that I take things in a slightly different direction, and I did, and the whole stream was supportive for that. And so we decided to basically do something a little bit better, I think, than my original solution. So I'm really happy for that. Anyway, bit of a streaming disclaimer. And also I'm actually recording this episode live on stream, as you probably saw from the chat in the beginning of the episode. So that's the new way that we're going to be moving forward with this Game Engine series. Anyway, without further ado, let's talk about how we would want to add functionality to this camera class. And I'll try and summarize all of the iteration kind of that we went through when we wrote this in the stream. And I'll kind of integrate it into the current version of Hazel as well. So the way that you would probably expect this to work is I want to be able to create a class such as camera controller, and I'm just writing it here for now, but it doesn't really matter. I want basically the standard entity kind of script functions that you would expect, such as Oncreate, which is a function that we can call, or rather a function that gets called when this entity, I can't write anything, when this entity actually gets created. So just like Unity, pretty standard. On update, which is a function that takes in a time step. I think we've actually got a time step, so we can just take that in. This is a function that gets called whenever we update. Whenever our game scene gets updated, and then all of the entities subsequently get updated as well. this gets called. And then, there's a lot of other ones. Like there might be one for like the destroying of entities. There might be one for like on awake or something if you want to maybe create them first, but then actually like awake them a bit later. There could be like collision callbacks. There's a lot of stuff. We're going to focus on these three here today. So with these three functions, and this is, by the way, exactly how you would expect this to work in C# as well. So you can probably see some similarities here. I mean, it's exactly the same, and that's the whole point. But these are native scripts, so they work a little bit differently. There's no script runtime sitting upon, like on top of this. This is all directly integrated with the C++ source code, so it should definitely perform faster. And this is always going to be an option. I think it's worth mentioning that the reason why we want to actually create this whole C++ scripting in the first place, instead of just blindly integrating, or rather straight away integrating C#, because that's what we're going to use for our scripting language, instead of just doing that, which we could have done, I'm not just doing a C++ first because it's easier. I'm doing it because it has a function, but also because people have been asking me, hey, is Hazel going to support scripting in C++? I really want that. I don't know C#, or I don't use C#, or I don't like C#. Can I still build games in C++? And in my opinion, the answer should be yes. So to make that a lot simpler than having to modify engine code to bypass the whole you have to have C# scripts thing, I want to also make native scripting a thing, and that's why we have this whole C++ layer. So because it is a native script, it has to differ from a regular script. So what we're going to do is we're going to, into the second camera, we're going to add a component called native script component. This is different from the script component of the future, which is something that will be C#. Well, most likely. I mean, it's going to definitely be C#, but we might also extend it with Lua in the future. I don't know. For now, it's going to be just the native one and the C# one. So we're going to add a new component into this second camera, and we need a way to provide this component with this camera controller class. So, I mean, let's think about how we can do that. What we could do is maybe like native script component is a component that takes in some kind of pointer to an instance of an object. So in other words, we could allocate camera controller here, I guess, and just pass it in like this, right? And then assuming that it has these functions, which we would somehow need to check, maybe it's like it inherits them from like, some kind of entity. Maybe we have a scriptable entity or something like that here. And then these are virtual functions and they're inherited from that. That's something that you could do. That's probably a simple solution. But we decided with the stream that we can do better than that, because as you probably know, virtual functions require a dispatch to happen. So in other words, every time we actually call this function, it needs to look up in the vtable what the overridden function is, if it's present, and call that. That's an indirect function call. That's not the best for performance. And of course, since this is a native script, we want it to be as close as possible to the actual function calls. We don't want any kind of indirection. That's what C# will end up doing anyway. So because of that, what we're going to do is we're going to use some magic to basically determine and bind all of these functions into the native script component that we add, so that the scene can then call these functions directly without having to go through the vtable. And that's what today's episode is going to be about. So how do we achieve this stuff? And we are still going to have it inherit from a superclass. The reason for this is there's not going to be any virtual functions, but the reason we want that is just to give access to some other useful functions. So for example, in the Oncreate function, we might want to retrieve the transform component. Well, the thing is, if this is not a subclass of some kind of superclass, if this does not derive from scriptable entity, how exactly are we going to be able to write this function? Well, we would somehow first of all need the scene as well as the entity ID from within the entity library, or the ent library. That's going to get a little bit complicated. Maybe if we had the scene, we could do something like this, but then again, we need the entity ID. The API becomes very messy. I really like the way that it's clean inside C# and inside an engine such as Unity. We still want to keep it like this, and that's why we have this to begin with. Okay, so I'm not gonna lie, I do have some reference code from this that I wrote during the stream because this is mildly complicated and a little bit finicky. So I'm gonna be referring to that, but in general, we should be good to go to start implementing this stuff. So the first thing that I wanna do is talk about this native script component and how we're gonna be able to bind to it. So long story short here, we're not going to be providing any kind of instance. This is another important thing that we need to think about. How exactly is this instance going to come to be? So we don't want to allocate it here. We don't want it to be allocated during the creation of, our components whatsoever. When we hit play in the editor and our game actually starts, we want to start instantiating these script classes like camera controller. So what we need to actually do is provide this native script component with almost like a blueprint. We really just need to provide it, if you think about it, with a bunch of lambdas or function pointers that are going to call these appropriate functions and then let the scene handle that at the right time. We don't have any concept of play yet, right? We don't have any concept of runtime yet, really. And so because of that, this is the editor layer. Because of that, we're going to basically simulate that today, but just know that there are some things here that will be done a little bit later. Okay, so to start this off, what I want to do is talk about the UI here. And in fact, let me just find the place where I wrote this stuff specifically. So the way that I made this work and the API that we used was basically we had this native script component, and then we added a function to it called bind. And the reason is we can't really take in another, I guess I could have made an overload or specifically add script here that added the scripting component for you. And in fact, this might be something that we do. This is fun. I didn't explore this during the stream, but we could write a function on the entity class called add native script that would make this a little bit easier. But for now, the way that it works is we do second camera.add component. So entity add component, native script component, which we're about to create. And then once we get that script component, it gets created, we obviously get it back as a reference. We can call .bind and then the name of the class we want to bind with. And that's it. And the script component and that bind function on the script component takes care of the rest. So it's really, really straightforward. And that's it. And so basically this is the whole API of what you'll need to do as part of your game or application if you want to add a behavior, add a behavior class really to an entity. So I think that's a really clean API and I honestly really like it. So let's make it work. So let's go to the components class. So what we're going to need here is a native script component. And so inside this native script component, what we want is, first of all, a pointer to the instance. Now, this is not stuff that you should create on your own. In fact, the only way to use this class is really by just adding it. So you go add component, native script component, and then you use the bind function. So I might make this stuff private in the future, but basically what we want to have is that scriptable entity. We still need to have a pointer to it. We're not going to be creating it ourselves. It's going to be up to the scene class to create it when this actual script entity gets instantiated, but we still need to have this. So I'll say scriptable entity instance equals null pointer. We'll have to make this class in a minute. In fact, we should probably take a look at making that now. So this script entity, and I'm not sure where to make this. I think that the best place to make this is probably going to be inside the entity class. Although it might be fair to, let's see if we can add this somewhere else. So we have seen entity, because I'll add it here for now. Maybe we'll add it into a different class in the future. So scriptable entity. So all scripts should extend from this class. And so actually, because we do that, we'll end up repeating the API a lot. I am actually going to go back and add this as a different header file. So scriptable entity namespace Hazel. We will include, going on today. We can include entity because we'll need to. What is going on today? Cherno can't write anything. Cherno's stumbling on the keyboard. All right, class scriptable entity. So this includes entity, and the things that it will really have is, first of all, it needs to actually have an entity, right? If it doesn't have an entity, then it has no way of interacting with the scene or itself. So if we want to call something like GetComponent, we obviously need to have an actual Hazel entity, which, as you should know by now, is an entity handle. as well as the actual scene pointer. Really important stuff. I'm also going to make this a friend of the class scene. So by doing this, I'm just letting the scene class access like the private members and functions and everything of this class. And then the cool thing is over here, I can add any functions that I want every scriptable entity to have. So stuff like the GetComponent function. So let's add that one in as an example. So we'll say, this is basically going to be a copy of this, isn't it? So we're going to basically copy this. It's just that instead of calling this stuff, we're actually going to return mEntity GetComponent. So it's really just a wrapper around that stuff. And, you know, I mean, this, whoops, what am I doing? And this should just get like, you know, inlined and optimized away, of course, by the compiler when we actually compile this stuff. So that's what it looks like. And now the cool thing with that is that, let's go into hazel.h. Let's include scriptable entity here. Maybe we'll put this into like a script folder in the future to make it a little bit better. But as you can see, we now have this, and I can now call code like this, and I should be able to get that stuff. So that's pretty cool. So now that we've got that, if we go back to the components class, we can take a look at adding the rest of this native script component. So the big one, of course, is the bind function. So what this needs to do is take in a type, take in a class, and then just figure out, how do I call the existing function? So how do I call the onCreate function? How do I call the onUpdate function? How do I call the onDestroy function? So of course, since it needs to take in a type, we'll make this a template because it needs to basically be able to bind to anything. And then over here, we need to set up a few functions. So we're going to use lambdas for that. Now they are going to be stored inside an std function. So let's just, for example, take the onCreate function. So this is the onCreate function. So to do that, we basically need to say that the onCreate function is going to call the onCreate function, it's worth noting that we obviously need the instance. So if we go back to here, let's take a look at this. So how do we call onCreate? Well, we need to have a camera controller instance. And then if we have an instance, we can just call, you know, instance pointer, whatever, arrow onCreate, and that's it. So to do that, if we take a look at this, if we just create a quick lambda, I mean, we need to somehow get the instance and then call onCreate, right? And that should work. So instance is up here. How do we capture that? Well, we could take it in by value or by reference. We're going to take it in by reference because it's really important. This isn't going to be set at this point at all. So we need to actually bind to this by reference. Actually, hold on. I don't think we need to do this at all. No, because what's going to happen is it's actually going to be passed in as a parameter. So we'll say scriptable entity pointer instance, and then we're just going to call instance onCreate. Now hold your horses. Scriptable entity doesn't have an onCreate function, right? If we did, like we could add that and we could make it virtual, and then we could make the camera controller override it. But we're not trying to do that. We're not trying to have any virtual functions here at all. No vtable, none of that. We want to just have the function that's on this type. So how do we do that? Well, we know this type, or rather we know instance is going to be of this type, right? I mean, we might as well take in a void pointer here. It doesn't really matter because of the way that we're going to control this. We're going to know how it's going to work, but I'm not going to take in a void pointer just to keep this a little bit more safe, I guess, or safe looking. And then so over here, what we really need to do is grab instance and cast it to a t pointer. So now instance is a t pointer, which in this case is going to be, if we go back to editor layer, we know it's going to be camera controller. And then when we create it, of course, we will create it as a camera controller. So that checks out, and we just call onCreate, and that's it. So check this out. We have onCreate. We can call it. Amazing. So first of all, how does the instance get instantiated? Well, to make that happen, we actually also need a function here that sets up this instance. So how do we make it actually create or instantiate our camera controller class or whatever our script class is? So we'll say instantiate func. I'll call these funcs just because, maybe not. You know what? Maybe not. We'll be all detailed here. So what is the instantiate function going to do? Well, I'm going to have it be a capturing lambda here that's going to actually take in the reference of this instance thing, right? So we could write this out like this if we wanted to. In fact, I think I will, just to make sure that that's the only thing we capture. Doesn't need any parameters. And then it's just going to set instance equal to new t. So this is worth noting that it's only going to work if our constructor here is, how should we say this? I do need a semicolon here. If the constructor has no parameters, if it does, we'll have to forward those parameters. Typically, you don't write constructors at all, right? If you look at like an example from Unity, when you create a new C# script, you don't write a constructor with a bunch of parameters. Or at the very least, if you do that, which is a bit weird because maybe you use it elsewhere, I don't know, whatever, you should probably have a default constructor. So that is a requirement that we do enforce here. But again, usually that's fine. We also need a destroy function. So you need to be able to destroy this instance a little bit later. So to do that, we are going to add that in. I didn't actually add that during the stream, but destroy instance function. I don't know if there's an opposite of instantiate, but basically destroy instance function will just delete this. And I guess, you know, if we wanted to in debug mode, we can also, so delete instance. Now instance needs to be of type T when we delete it, otherwise we'll have some issues. So we just need to make sure that we're actually casting that to T. And then, you know, just to make sure that the destructor of our, you know, camera controller class in this case gets called, just in case we allocated memory. This shouldn't happen though. That's the thing. We're deleting this because it's heap allocated and we need to, but you know, we probably want to be a little bit smarter about how we manage memory. That's a discussion for another day, but basically this instance gets deleted. So we have this function as well. I think that's all we need to do. And again, if we wanted to, we could also set instance to null pointer, maybe only in debug mode or something like that in the future, just to make sure that that actually works. Okay, cool. On create, let's create the two other functions that we have. So we have on destroy, and we have on update. So on destroy is also going to be a void function here. And it's just going to call, so we'll do on destroy, it's going to call on destroy, and then finally on update. And on update is going to call on update, but we also need the time step. So we need to take in float TS here, or rather time step TS over here. And I'm also going to mark this as accepting a time step, of course. So these are our functions. Now, one quick note I want to add is that std function, we recently removed bind from the engine because bind actually, std bind allocates memory and it's a little bit, you shouldn't be using it. Std function does not allocate any memory. Usually, or at least in my testing, it hasn't. So I have yet to do additional extensive testing to make sure that it's fine, or just maybe reading the source code would be a good start. But as far as I'm aware, this should not allocate, the Lambda itself should not allocate memory, even if it is capturing. So that's also worth noting. std bind is the evil thing that we didn't want to use, not std function as far as I am aware. Okay, so we have all of these functions, fantastic. So now if we go to the editor layer, and we have all of this stuff here. First of all, let's do a quick compile, Control F7, just to compile this one file, make sure all of these templates check out. Of course, they don't. A Lambda capture must be available from an enclosing function scope. Okay, oh, because we need to capture this in that case, sorry. So to make this happen, we need to kind of capture this and then do this instance. But if you just leave an ampersand here, I think it should work because it should figure that stuff out for you automatically. All right, now we have no, blah, blah, what's this? So we're doing a right hand of bind Lambda. There's no acceptable conversion from this. Why is that the case? It's a void function, isn't it? So as far as I'm aware, that should, oh, sorry. Well, for this stuff, it's not working obviously because we need to actually take in a scriptable entity. So these std functions obviously need to take in a scriptable entity as a parameter. These two don't because they just affect instance. I think that's it. Yeah, all right, that's it. Yeah, of course, like we could take in the component. If we really didn't want to capture in Lambda, we could definitely make it work. We would just need to take in the component itself or a reference to this pointer, and then we could assign to it. And in this case, it could even be copied. So we could make this a parameter in the future if we wanted to, but I think doing it this way, at least for now, is fine. Okay, so now that we've got that, I believe we can compile our code and it should work. Great. So let's test it out. Or rather, before we test it out, we should talk about what this actually does, because at the moment it does nothing. So the point of this is we've now binded these functions. They're now bound to be inside the component class, right? So in other words, this native script component now holds references to all of those functions. It can now call them. So what we need to do is we need to go to the scene class and we need to actually make them do something. So this is all of our rendering code inside scene on update. What we need is the update scripts. We need some script updating code. Now, onCreate should definitely happen. This onCreate function should definitely be called when we create, and then destroy needs to be called when we destroy, but none of that stuff happens yet because we don't have we don't have this concept of let's start the game now, or the runtime has begun. We don't have that yet, and as a result of that, there's no point in making that do anything yet. So because of that, we're gonna simulate it. We're gonna basically iterate through all of the entities that have that native script component. And then if instance is set to null, we're going to run the instantiate function, which is going to create it. And then when we create it, that way we know that, okay, it exists now. Now we can call the onUpdate function to actually update the entity. And I guess as part of it, we'll also call onCreate. So to iterate through all of our update scripts via n, of course, we need to create a view. So I'll do this in a slightly different way that's a little bit more optimized. Instead of actually writing auto view equals m registry view, I'm going to take a view of just the native script components. We can't use groups here because we're just going through a single component. And then I'm actually going to write .each. And then this lets us provide a lambda that will be called for each of the entities that have a native script component. So I'm going to add in the entity, and I think it needs the actual native script component, which we'll call nsc. Let's fill out the rest here. And then our goal here is really just to, as I mentioned, see first of all, if this whole instance is null or not. So if it's null, right? If that instance doesn't exist yet, and thank you Visual Studio for ruining everything. If it doesn't exist yet, then we want to call that instantiate, and Visual IntelliSense is just not helping at all. So I'm going to have to see what this is. This is obviously a void function, so it's it doesn't have any parameters. We just call it like this. We should now have a valid instance, and we can definitely check that to make sure it works, but I don't think that's necessary. Now we've got a valid instance, we can call the onCreate function. Now notice that to call the onCreate function, because I decided not to write it as a binding lambda, which I could have, obviously, I could have just done this, and then that way we didn't need this parameter, but we've decided to do it this way. So I need to pass in nsc.instance like that, and now the onCreate function should get called. Finally, outside of this, so every frame and every time, for as long as this exists, obviously, I mean, if it doesn't, it'll create it, which should happen on the first frame, I guess. But then on the first frame after it's created, and also on every subsequent frame, we want to obviously call the onUpdate function. And we want to pass in the instance as well as the time step. So instance and TS is the time step, and that's it. So now, technically, at the beginning of each scene update, any entity that has a native script component will have its create function and update function called. And the update function being called every frame, obviously. So to test this out in a very easy way, let's just print out the time step. So time step TS, and of course we'll test out the, don't really care about this. Let's test out the, let's just say onCreate. We'll test out the onCreate function by just writing this. Okay, let's hit F5 and let's see if this works. No, it doesn't, because we have some, oh yeah, so what happened to this? This completely, I guess we didn't include this. So scriptable entity needs to be included. Hopefully that will work out for us. Although, yeah, because I don't think we include the component header file inside the other one, so we should be okay. All right, look at this. So we have our time step being printed every frame, and then hopefully the first frame we have onCreate, okay? So you can see that we're now able to essentially write some scripting code as easily as this. Pretty cool. So let's test this a little bit more extensively. Let's try and do what we wanted to do last time, which is basically make that camera move. So how can we make it so that maybe like the WASD keys or whatever would move this stuff? So first of all, let's grab the transform component. We can grab this, well, let's just keep this really simple. This code really simple for now. Let's grab it inside the onUpdate function. So dot transform, I believe, is what we're looking for. We'll take a reference from that. We now have transform. And now, since this is part of C++ code, right? It's got the whole C++ API that we have available to us. We can just write if input is key pressed. Let's make it the W key, for example. So if we'll start with the A key. So we'll make it move left. So to move left, we just need to say transform. So let's get the third column of the matrix and the first element of that column, which is the X translation, and we'll subtract it by some kind of speed. So we'll write float speed maybe equals like 5 or something like that. And we'll subtract it by speed times time step. So let's do that. DWS. So D will make it move in the positive X direction. W will make it move in the positive Y direction, which is the first element of that third column, and sorry, the first index, which is the second element of the third column, and then S will make it move down. Okay, I think that's correct. So remember, we're modifying the camera's transform. This is not the view matrix. This transform will be inverted to create the view matrix. And since we're taking a reference of this, we should just be, we don't need to assign it back or do anything like that. This should just work. So let's hit F5 and let's see if we have now added behavior to our camera class, in which case that I think would be pretty cool. Let me unselect my console. And we crashed. Oh, it was almost perfect. So apparently it's saying that we don't, oh, no, I forgot to do something extremely important. So I'm actually glad that happened because I was almost about to end the episode. Obviously, right now, if we call GetComponent, it's going to try and get the component from the entity, but guess what? The entity has never been set. We need to actually set the entity. So how do we do that? And in fact, guys, to be honest, I don't remember how we did that. Oh, okay, I see. We just did it in the Instantiate function. So to do that, we're going to go back to our scene class, and then inside the Instantiate function over here, and there's a few different places you could do this, but now that we have the instance, we can just basically, before we call Uncreate, we can say instance mEntity equals entity, just like that. Except entity, of course, is the ent ID, so we need more than that. We also need this because that's the scene pointer, and we should have an entity. And I'll try and actually make sure that it actually recognizes that type, and this will probably make a little bit more sense to read as well. Take two. Let's hit F5 and let's see what we get. So now we're actually telling our scriptable entity which entity it belongs to. All right, does it work? It does not. I don't see any update happening here at all. This is not going as smoothly as I was hoping it would go. I wonder why that's happening. We're still binding to it. It's still calling on update, or at least it should be. The only thing I can think of is that this GetComponent function might not be working correctly, although I imagine it should be. Let's try and debug this. So let's hit F5 here. So if I press this transform is obviously, oh, right, of course. I think it is working. I just forgot that we're modifying the second camera. So if we uncheck camera A, and we now take a look at this, you can see we are now able to move our camera. False alarm, everything's working fine. So there we go. And then of course, if we wanted to add this to the first camera or something like that instead, let's just grab camera entity. Let's add this to the camera entity instead. Suddenly we now should be able to have that same behavior on our first camera, which should be pretty cool. So yep, there you go. Now if I uncheck that, I can't move this camera, but I can move my first camera. And that is the basic way that we are going to be able to add scripting in C++ to our entities. Now, there's one thing that I want to note, and this is the kind of more advanced part that we went into during the stream, and we will address this in the next episode because this took a while anyway. But essentially, we have a bit of a problem, and that is that what if we don't provide all of the possible functions? So, for example, what if I don't want to, like, onCreate, onDestroy, do nothing? I want to keep my class really simple. I just want to do that. Is that going to work? And the answer is, well, no. Because as you can see, the template does not compile correctly because onCreate is not a member of this. So when it tries to actually bind this function, it can't because onCreate is not a function that exists on T, which is a camera controller. So how do we make it maybe only bind the functions that exist? Well, there are a few ways to do this, and to be honest, I'm not sure exactly how many ways there are to do this, but the best way to solve this is via some template metaprogramming, where basically we can check to see the type traits of this T class and see whether or not this function exists. And then if it doesn't exist, we can use a if const expr. We can use a little constant expression here to, at compile time, decide to just not even compile this Oncreate function code whatsoever if the Oncreate function was not provided. And then of course inside scene, we need to check to see if this function exists. And if it does exist, we can call it. And same with the onUpdate function. So we can check to see, hey, has onUpdate function been set? And if so, call it, otherwise don't. So that is something that we will tackle next time, because it definitely deserves an episode of its own. There's lots of fancy template code that needs to be written there. But otherwise, if we just leave our onCreate and onDestroy functions like this, then I think we should be pretty okay. So let's check this out. Yep, everything works. All right, guys, hope you enjoyed this video. If you did, please don't forget to hit the like button below. And if you're watching this on Twitch, don't forget to follow the stream. You can also help support this series and me and everything that I'm doing by going to patreon.com/the Cherno, where you'll get access to some fancy benefits, such as I mentioned, these streams recorded in kind of an archive format that you can go through, as well as the source code to Hazel Dev, which is a much more advanced version of this, with like 3D rendering and like, you know, C# scripting and like a real editor and all that stuff, if that is something you're interested in. Anyway, thank you guys for watching. I will see you next time. Goodbye.